Okay. It's wintertime in the prairies, and while that doesn't preclude us from outdoor demonstrating outdoors on largely dormant plants felt less interesting and diverse than just coming inside to the grocery store. So we're here at the grocery store, and we'll attempt to demonstrate the awareness that botany brings to grocery shopping experiences. As a shopper, it's often desirable to prioritize flavor. And what better place to start the discussion of botany in the grocery store than with ripeness? When we're talking about ripeness, many sensory qualities come to mind that correlate with the changes that occur within the fruit as they ripen. Increases in water content. Fruits become more juicy as they ripen. Pigmentation, as their coloration becomes more alluring. Sugar content also attracts hungry dispersal animals, and they become more sensitive to ethylene gas. They decrease in pectin content, so you wouldn't get the same gelling from an older, more ripe fruit than you would from a younger fruit when you're making jams. The starch content decreases, with more of the starch being converted into sugars. The acidity decreases, which is surely an evolutionary tactic to deter consumers prematurely. Chlorophyll content, which would allow fruits to better contrast with their predominantly green background. Now we will head over to the bananas. Follow me on our journey through botany. Of course, much of the ripening is ongoing here at the store, something shopkeepers have to manage, especially for what are called climacteric fruits, like apple, as we saw before, avocado, apricot, bananas, papaya, peaches, pears, plums, and tomatoes. While bananas will ripen much on your countertop at home, that is an example. However, this is less of a concern for fruits like cherry, which we don't see currently. For cherry, figs, grapes, citrus, as we saw with the orange, pineapple. Those are known as non-climacteric fruits, which won't continue to ripen once they've been separated from their plant. Harvesting these fruits occurs once they've reached optimal ripeness. These fruits are all fruits will, however, continue to respire, which is another important consideration for management of spoilage. This way, to the lettuce. They went back to their... This way, to the lettuce over here. By controlling temperature, oxygen, and ethylene production, or concentrations in the ambient environment, distributors are able to package things with high respiration rates like lettuce. If you're shopping for any particular type of fruit, it might become useful to know the different types. Please, follow me as we go to an apple. Of course, palms, like apples, have thin exocarps with succulent mesocarps, but unpalatable endocarps. Berries, of which only these kiwis are one of, house many seeds with fully edible endocarps, mesocarps, and exocarps. Drupes. None of these are drupes. Have inedible pits, like rocks, to survive digestion. And what are more commonly referred to as berries, like these raspberries, are actually aggregate of many small fruits produced by many small ovaries that have been fertilized. And strawberries, of course, strawberries. which are actually an accessory fruit to hundreds of smaller fruit that stud the exterior, known as achenes. Many of these fruits only begin development after fertilization. And if incomplete fertilization occurs, you can actually tell which seed was successfully fertilized by observing fruit development. Occasionally, you'll find a lopsided fruit, like an apple. And when you do find that, you can determine which seed on the interior was fertilized by which hemisphere of the apple was improperly formed. Next, we will, of course, fruits are but one edible portion of plants here at the store. Other botanical structures than reproductive features are also exploited by humans for edible stuff. The store is virtually bursting with stems, roots, leaves that have collectively been adapted to storage organs. Celery's edible features are actually the base of leaves, known as petioles. You can determine this by, if we were able to peel these open, you would be able to look for axillary buds at the base of each leaf. Similarly, follow me. Well, fennel. Actually, let's go to onions. Oh. Similarly, fennel has modified leaf structures. Also, this way. Onions are also just modified leaf storage units. Carrots and parsnips, on the other hand, utilize modified roots as storage strategies to allow them to winter as biennials. You can tell each are dicots because of their engorged taproots. Carrots. Beautiful. Beets as well. Alright. Potatoes, this way. Potatoes and ginger, however, are stem structures. Potatoes, known as tubers, will actually develop axillary buds at the branching points. Let's see if we can find one. There's the development of what are known as ears, which is actually an axillary bud. Ginger, if you'll follow me, is a rhizome, an underground stolon, also a stem structure, facilitating reproduction. Broccoli humans have actually been manipulating these elements for millennia. A great example of this is the breeding regimes of Brassica oleracea, the selective breeding of which has given us kale by way of selective breeding of leaf development. Brussels sprouts, not in picture, for axillary bud development. Cabbage for apical bud development. Broccoli and cauliflower for floral development. Corn, which is gone, is another highly selected plant, having been diminutive grass before being bred into what it is today. One of the few monocots we'll discuss today. We can tell this by observing leaf venation of the plant in parallel. It is also monoecious, which is to say it has a male tassel at the top and female ears, each on a singular plant. That's all the time we have for today. I will get on with my groceries now. Goodbye.